In the interior of a Mesopotamian temple storehouse, at some point near the middle of the day, the air is noticeably cooler than the street outside. The mud brick walls are thick enough to hold the night's cold well into the afternoon, and the smell of the place is dry and dense, grain dust and sealed clay, the faint mineral scent of earth that has been shaped by human hands and left to harden in the sun. Clay jars stand in rows along the walls and across the floor in careful arrangements, each one sealed at the mouth, each one holding a measured quantity of barley. The light comes in from a single high opening, falling in a narrow column across the packed earth floor. A man sits just at the edge of that light, with a soft tablet resting on his knee, pressing the blunt end of a cut reed into its surface in short, considered strokes. He is not writing in any decorative sense. He is recording a number. Somewhere outside, a quantity of grain has been promised to someone, and that promise now exists as marks pressed into clay, and those marks, once the tablet dries hard in the sun beside the doorway, will mean something to anyone who can read them. This is not poetry, it is arithmetic, but it is also, in one of the oldest and most practical senses possible, money. The idea that money is an ancient human invention is easy to accept in the abstract. What is harder to hold on to is how physical it was at the start. Not abstract at all, not a concept or a policy, something you could lift, smell, pour into a jar, or feel pressed between two fingers. The earliest systems that served the function money now serves were built entirely from things that already had weight and substance in the world. Grain, metal, shells, bronze cast into shapes, and the slow process by which those tangible materials became something that could stand in for value across distances and between strangers is one of the quieter revolutions in the long story of how human beings organize themselves. Before any of those systems existed, trade worked on a principle that sounds straightforward but created an enormous number of practical problems the moment economies grew past a certain size. If one person had grain and needed linen, and another person had linen and needed grain, a trade could happen easily. The difficulty was that this coincidence had to hold for both parties at once. A weaver who needed grain, but whose neighbor happened to need shoes, not fabric, was stuck. The farmer who had extra barley, but needed a clay pot, could not trade with the potter if the potter's current need was not barley. Economists refer to this condition, the requirement that both sides of a trade possess exactly what the other party wants, in the right quantities, at the same moment and location, as the double coincidence of wants. In a small community where the same few people traded with one another regularly, the problem could be navigated through trust and informal arrangements, promises tracked in memory and settled over time. As economies extended outward, as towns grew and routes of trade lengthened across regions and eventually across continents, the coordination problem became increasingly difficult to manage without something that could act as a go-between, something that one side could accept even if they did not immediately need it, confident they could trade it again to someone else who did. The temple warehouse in Mesopotamia was one of the earliest solutions to appear in the historical record, and it worked partly because of the specific role temples played in early urban life. The great temple complexes of ancient Sumer and its successor civilizations were not only religious centers, they were also administrative centers, redistributive hubs where agricultural surplus was gathered, recorded, and distributed to workers, craftspeople, and priests according to carefully maintained accounts. Grain moved in and out of those storehouses in measured quantities, and the quantities were tracked on clay tablets using a counting system that had, over the course of several centuries, become standardized enough to be used across wide areas. By approximately 3000 BCE, the accounting systems in use across ancient Mesopotamia had become sophisticated enough that grain stored in a central warehouse could effectively function as a medium of exchange. A farmer who delivered barley to the temple received a record of the quantity delivered. That record could be used to claim an equivalent value of something else from the temple stores, or it could be transferred to a third party as payment for labor or goods. The clay tablet was not the money itself, exactly, but it made the grain function as money across distances that the grain itself could not travel easily. Silver entered the picture alongside grain, and the two worked in parallel for a long time in ancient Mesopotamian economies. Silver was measured by weight in units called shekels, a word that has survived through thousands of years of linguistic change to remain recognizable in modern usage. A shekel, at its origin, was simply a unit of mass, the weight of a specific number of grains of barley, which is itself a reminder of how deeply those two forms of stored value were intertwined in the thinking of the people who used them. Silver was not yet stamped into coins at this stage of history. It circulated as rings, ingots, and irregular pieces that were weighed on a scale each time they changed hands. The weighing was the verification. The scale and the weight were the instruments of trust, ensuring that what was being exchanged corresponded to what had been agreed. Clay tablets recorded these silver transactions the same way they recorded grain quantities, and together the two systems gave Mesopotamian merchants and administrators a set of tools for tracking obligations and transfers that was flexible enough to handle the complexity of large-scale trade across hundreds of miles of river and road. Far to the east and south, on and around the low coral islands of what are now the Maldives, a very different material was finding its way into the currents of trade that flowed across the Indian Ocean and beyond. Cowrie shells, smooth, small, oval, and slightly lustrous, were gathered by hand from the shallow, warm water around those islands by people who had been doing so for as long as the practice could be remembered. The shells of the species known as Cyprea moneta are uniform enough in size and shape that they could be counted and sorted with a consistency that made them useful as a medium of exchange. They were durable. They could not be easily faked or manufactured in quantity by anyone who did not have access to the specific coastal environments where they were found. They were light enough to carry in large numbers without great difficulty, and they were visually attractive in a simple, quiet way. Smooth to the touch, their surface slightly glossy, catching the light with a pale warmth that made them pleasant to handle. The shells gathered in the Maldives traveled extraordinary distances. They moved west along Indian Ocean trade routes into East Africa and deep into the African interior, where they circulated as currency for centuries and in some regions into the 19th century. They moved east and north into South Asia and eventually into China, where their use as a medium of exchange appears in records dating to the Shang dynasty, around 1200 BCE. In China, the cowrie shell left a mark on the written language that persisted long after the shells themselves had been replaced by other forms of money. A large number of Chinese characters that relate to commerce, trade, value, and wealth include the radical for cowrie shell as one of their components, a visual trace in the structure of the written language of the time when shells gathered from a warm ocean, thousands of miles away, where how value was stored and moved. The shells traveled so widely and remained in use for so long in so many different cultures that they represent one of the most geographically extensive and temporally persistent forms of currency in the entire human record. A Maldivian fisher lifting a shell from shallow water and placing it in a woven basket probably did not think of the transaction in those terms. The shell was just a shell, but the same shell a year or two later might be in the hands of a merchant in East Africa or a market stall in Bengal, or pressed into the soil of a burial mound in the Chinese interior, standing in for a quantity of value that existed only because enough people agreed that it did. The process by which metal gradually displaced other materials as the primary medium of exchange was not swift or uniform. Different cultures arrived at metal currencies by different routes, and in some parts of the world, shells and grain and livestock remained central to exchange long after bronze and silver coins had become standard elsewhere. In China, the transition moved through an intermediate stage that is worth resting on for a moment, because it captures something about the particular way a culture thinks about value and utility when it is in the process of developing a monetary system. During the Zhou dynasty, which held nominal authority over much of China for roughly 7.5 centuries, spanning from around 1000 BCE to 255 BCE, the objects used as currency in markets and for larger transactions included bronze castings made in the shapes of agricultural tools, miniature spades and miniature knives cast in bronze served as mediums of exchange across different regions of the Zhou sphere of influence. These were not functional tools, they were too small and too precisely cast for agricultural use, but they carried the symbolic weight of the real objects. They resembled tools that had genuine and understood value in an agricultural economy, and that symbolic connection gave them a kind of credibility as stores of value that pure ingots of metal might have lacked in a culture where the link between value and useful physical things was still close to the surface of economic thinking. A craftsman working a clay mold in a Zhou dynasty workshop, pouring molten bronze into a form shaped like a miniature spade, no longer than his hand, was producing something that would move through markets and change hands dozens of times before finding its way back to a smelter or into the earth where archaeologists would find it 2,000 years later. The spade money of the Zhou period has a quality that sits somewhere between tool and coin, between practical object and abstraction, and that in-between quality is part of what makes it a useful thing to think about when tracing the long arc of how humanity arrived at money in the form that most of the world now uses. The round bronze coins with square central holes that eventually replaced spade money and knife money in China carried a design that was itself deeply practical. The square hole allowed many coins to be threaded onto a cord and carried in counted bundles, so a merchant could keep 1,000 coins on a single rope and count them by moving along the cord without ever needing to separate them. The coins themselves became a slightly more abstract object than the spade-shaped predecessors they replaced, but the string of holes threading through them kept them physical, tactile, grouped into bundles that could be felt and counted by hand in a busy marketplace without close attention to each individual disc. The electrum of the Pactolus River in ancient Lydia was a natural alloy, gold and silver mixed by geological processes in proportions that varied from one deposit to another. And it was this river metal washed out of the hills of what is now western Turkey and collected from the stream banks that the Lydian kingdom's craftsmen used to produce what most historians consider the world's earliest standardized coins. The date most commonly associated with this development is around 600 BCE, though the exact moment is difficult to pin down precisely, and the coins did not appear all at once as a sudden invention, but developed gradually as a refinement of earlier practices of weighing and marking metal. What distinguished Lydian coins from simple weighed metal was the stamp, a lion's head pressed into the surface of each coin under the force of a die meant that someone, the authority behind the stamp, the Lydian royal house, had certified the weight and composition of that particular piece. A trader who received a stamped coin did not need to produce a balance scale and a set of weights to verify what they were getting. The stamp was the verification, or rather, it was a promise that the verification had already been done by someone with the authority and the means to ensure it was accurate. This is a small shift in terms of the physical materials involved. The electrum was the same, the weight was the same, or roughly the same, but the stamp transformed the object's social function in a way that had lasting consequences. It made trust portable. It allowed a piece of river metal to carry, along with its physical substance, a guarantee that traveled with it across distances and between strangers who had no prior relationship and no shared context beyond the coin in one hand and the goods on the other. The Lydian kingdom sat in a geographic position that made it a meeting point for several of the ancient world's significant trade currents. Greek merchants from the Aegean coast traded with Lydian merchants, who in turn connected to routes running east toward Persia and the wider Near East. The coins that emerged from Lydian mints circulated into this network and encountered the same practical problem that weighed metal had always faced: variability, but now with a partial solution already pressed into their surface. A Greek merchant examining a Lydian electrum stater did not need to weigh it against a known standard if the lion's head was clean and consistent. The stamp said what it said. Whether the merchant trusted that promise depended on the reputation of the authority behind the stamp, which was itself a function of whether coins bearing that stamp had proven honest in past transactions. Trust built on trust, slowly and practically, the same way most durable human arrangements are built. The challenge with electrum as a monetary metal was precisely the variability that characterized it as a natural material, because the gold-to-silver ratio in electrum differed between deposits and even within a single deposit, and coins of identical weight could contain meaningfully different amounts of gold and therefore represent different actual values in terms of the precious metal content that gave them their underlying worth. Lydian craftsmen eventually found a solution by learning to separate gold and silver from electrum through a process involving common salt and heat, which allowed them to produce coins of pure gold and pure silver with consistent composition. These came to be called Crossed coins, associated with the reign of King Croesus of Lydia in the mid-6th century BCE, the same Croesus whose name became a figure of speech for extreme wealth in multiple ancient languages, a reputation grounded in the gold-bearing rivers of the Lydian landscape and the monetary system his kingdom helped develop. The adoption of coinage spread outward from Lydia into the Greek world with a speed that suggests the form solved a problem people were ready to have solved. Greek city-states began minting their own coins in the 6th century BCE, and the practice reached Persia, India, and eventually Rome through a combination of direct contact and independent development. Each culture that adopted coinage adapted the form to its own needs and symbolic vocabulary, placing different images on the face of coins: gods, rulers, animals, symbols of civic identity, but the underlying structure of the stamped metal disc as a portable, standardized, authority-certified token of value proved stable enough to persist across enormous geographic and cultural distances without losing its essential character. There is something worth pausing on in the sheer geographic range across which these early monetary forms circulated, from the cowrie shells of the Maldivian coral shallows, moving deep into the African interior, to the Lydian electrum traveling east toward Persia and west into the Greek islands. The movement of these objects across the ancient world was not incidental to their function as money, it was central to it. The whole point of money, in the most basic sense, is that it can go somewhere that the goods it represents cannot go. A warehouse full of barley in a Mesopotamian temple storehouse cannot travel to another city. A clay tablet recording the quantity of barley can travel, and a silver ring representing its value can travel farther still, and a coin stamped with a lion's head can travel to places where no one has ever seen a Lydian temple or a Pactolus riverbank, and still convey its meaning clearly enough to complete a transaction. Distance was the problem that money was built to solve, and the widening radius of each successive monetary form, from stored grain to weighed metal to stamped coin, traced the widening of the human world itself. Along the trade roads that connected the ancient Mediterranean to the Near East, small groups of merchants would have moved with packaged goods on the backs of animals or in the holds of boats, carrying among their supplies a selection of coins minted by different authorities in different cities. The Greek world alone produced coins from dozens of city-states, each with its own imagery and each with its own reputation for the reliability of its silver content. A merchant who moved regularly between Athens and Corinth and Ephesus would have developed an informal expertise in the relative trustworthiness of different mints, knowing from experience which coins could be accepted without close inspection and which required a more careful look or a verification against a scale. This expertise was itself a form of value, knowledge about money, accumulated through experience and exchanged informally among traders who needed it. The Lydian system that set this all in motion was not, of course, the only path by which metal coins could have developed. In India, punch-marked silver coins called karshapanas were being produced around the same period, bearing symbols stamped from separate punches rather than cast from a single unified die, and the tradition of coinage that developed in South Asia followed its own logic and design vocabulary, while arriving at many of the same practical conclusions about what made a coin trustworthy and useful. In China, as already described, the path moved through bronze tool shapes and round perforated discs before arriving at the coin forms that would remain standard there for more than 2,000 years. The convergence of so many different cultures on the basic form of the stamped metal disc, through different materials, different imagery, different institutional arrangements, suggests that the form itself answered something fairly fundamental about the requirements of exchange that cut across particular cultural contexts. The cowrie shell gatherer in the shallow coastal waters of the Maldives, working in warm light with a basket filling slowly beside them, did not share a language or a cultural context with the Zhou dynasty bronze caster pressing a mold shut over hot metal, or with the Lydian die cutter engraving a lion's head into hard metal in a royal workshop. But all three of them were working, in their different ways, on the same problem: how to make value portable, verifiable, and trusted by strangers. The solutions they arrived at were as different as the materials and contexts they had available. What they had in common was the underlying need and the practical intelligence that recognized objects could be made to carry meaning beyond their own physical substance, that a shell or a spade-shaped bronze casting or a stamped disc of river metal could stand in for something agreed upon, could carry a promise between people who had never met and might never meet again. A smooth cowrie shell, lifted from a Maldivian shallows and placed in a basket, would be cleaned and sorted before being packed for trade. The sorting process itself was a form of standardization, selecting shells that met informal standards of size and condition, setting aside broken or malformed ones, creating a quantity of objects that were uniform enough to be counted and accepted without close individual inspection. This quality, the capacity to be counted without being individually evaluated, is one of the things that makes any object suitable for use as currency. A bag of carefully sorted cowrie shells and a roll of coins share this property. Both can be handled quickly in a transaction because the units are interchangeable. One is as good as another, and the count is all that matters. The technical term for this property, fungibility, arrived in economic thinking much later than the shells themselves. But the Maldivian traders sorting their morning's gathering were already applying the concept before the word existed, selecting for it practically and without needing to name it. There is a particular quality to the objects that endure as monetary forms across long periods and wide distances. They tend to be durable enough to survive handling. They tend to be available in consistent enough supply that the economy they serve can grow without running out of the material it runs on, but not so abundant that acquiring large quantities is trivially easy. They tend to be portable enough that a useful amount of value can be carried by a single person without undue difficulty. And they tend to be recognizable enough that strangers can assess them quickly and with some confidence. Cowrie shells met all of these criteria in the specific geographic and cultural contexts where they circulated for most of the several thousand years of their monetary career. When they failed, when they became too abundant, through new trade routes bringing large quantities from previously inaccessible sources, their value collapsed in the regions where they had been scarce, and they were displaced by other forms. But for the long stretch before that happened, the simple shell of a small sea creature solved the problem of exchange across an enormous portion of the ancient world with a quiet efficiency that more deliberate inventions took centuries to match. The Lydian electrum stater, pressed flat and stamped with a lion, resting on the open palm of a merchant somewhere along an ancient trade road in the 6th century BCE, was in one sense an extremely local object, made from metal pulled from a specific river in a specific small kingdom, stamped with the symbol of a specific royal authority. In another sense, it was already something more than that, already in the process of becoming the model for a form of monetary object that would be reproduced in dozens of materials, thousands of designs, and scores of different currencies across the following 2.5 millennia. The stamp said that someone had vouched for this thing. The metal said it had substance. The weight said it could be verified against any other standard the receiver chose to apply. And the fact that it could be carried in a coat pocket or a small pouch across mountain passes and sea crossings and market days in cities the original maker had never imagined meant that the promise pressed into its surface could travel wherever the coin travels, settling quietly into the palm of a new stranger and beginning the process of establishing its own small credibility all over again. That process, the repeated small establishment of trust between a coin and a stranger, played out in markets and on roadsides and at harbor docks across the ancient world, was the mechanism by which money became, over time, the thing we understand it to be now. Not a single invention, not a decree from a single authority that changed everything at once, a gradual accumulation of practice, tested over thousands of transactions in dozens of cultures, refined into forms that worked well enough to persist and spread, while forms that didn't work quietly fell away. The clay tablet drying in Mesopotamian sunlight beside a storehouse door, the shell lifted from warm shallow water and placed in a basket, the bronze spade coin cooling in its mold, the stamped disc of Lydian river metal pressed flat on a merchant's counter. Each of these was a particular answer to the same question, arrived at in a particular place and time by people who needed a solution and found one. A Lydian coin stamped with a lion's head, resting on a merchant's open palm, somewhere along a trade road near the Aegean in the 6th century BCE, is a small and ordinary seeming object in physical terms. A disc of pale yellow metal, smooth on the back, lightly marked on the face, warm from the hand that held it before. Its weight is precise enough to matter. Its stamp is clear enough to read. And its meaning, the agreement it represents between the authority that issued it and the person who holds it and the stranger about to receive it, is not visible anywhere on its surface, not pressed into the metal along with the lion's image, not scratched into it or written beside it. The meaning exists between people in the space of agreement and expectation and accumulated experience that makes a small stamped disc of river metal worth exactly as much as enough other people agree it is worth. And in that sense, what the Lydian mint produced along the banks of the Pactolus was not only a coin, it was a quiet and durable form of collective trust, pressed into metal and sent out into the world, carrying its promise wherever the road led next. A merchant on a road through the interior of China, sometime in the middle years of the Tang dynasty, would have carried his wealth in bronze, not in a pouch or a wallet, but in a chest. The coins of that era were heavy, dense things, each one a small disk of metal with a square hole at its center, and when enough of them were assembled to represent a significant sum, they became a logistical problem as much as a financial one. A mule could carry them, a man could not carry very many, and the roads that wound through the mountain passes between major cities were long, slow, and subject to the kind of difficulties, washed-out paths, unreliable inns, the ordinary hazards of distance that made traveling with a chest of coin both uncomfortable and inadvisable. The weight was not a small matter. Bronze is among the denser common metals, and the coins used in Tang China, called Tong Bao, were cast in large quantities but were individually modest in value, which meant that even a moderate sum required a considerable number of them. A merchant transporting goods between, say, the capital Chang'an and a trading city to the south or west would have needed animals simply to carry the money required to conduct his business along the route. The coins jangled, they slipped in damp conditions. They were, by any practical measure, a burden that the value they represented did not justify. What emerged from this problem was one of the more quietly clever arrangements in the history of exchange. Rather than transport the coins themselves, a merchant could deposit his bronze at a reliable house in one city and receive in exchange a written document, a slip of paper folded and stamped with identifying marks that certified his deposit. He could carry this paper on his person, tucked into his clothing, and when he arrived at his destination, he could present it at a corresponding office and receive coins in exchange for it. The paper traveled where the bronze could not conveniently go. The weight of the transaction had been reduced to nearly nothing. These certificates were called feiqian. The word translates approximately as flying money, a name that captured something precise about how they worked. They moved quickly, in the way that paper moves, without the friction of metal and transport. A single folded document could represent a sum that would otherwise require a pack animal to carry, and it could be settled at the other end of the journey as readily as any physical coin. The value had not changed, only the form that carried it had. The flying money arrangement was not at first a government system. It grew out of the practical needs of merchants who regularly operated across large distances, and the houses that issued the certificates were private commercial establishments whose reliability rested on reputation and the mutual interest of all parties in maintaining a workable system. A certificate was only as good as the house that issued it, which meant that trust was the underlying medium of the whole arrangement, more fundamental than the paper itself. The paper was evidence of the trust. It was not the thing itself. It is worth sitting with that distinction for a moment, because it runs through the entire history of paper money. Somewhere in a city, hundreds of miles from where a merchant presented his certificate, there were actual coins sitting in an actual room. The paper was a claim on those coins. It pointed to something physical, but the moment a person accepted that piece of paper in exchange for goods, rather than demanding to see the coins themselves, they had agreed to treat a piece of paper as if it were the thing the paper pointed to. That agreement was the beginning of something that would take centuries to fully develop. The Tang dynasty's flying money remained a convenience for merchants rather than a general currency. Ordinary people still transacted in coin. The certificates circulated among those who had the commercial relationships and the geographic reach to make use of them, which meant they were tools of trade rather than tools of daily life. The broader transformation, the moment when paper money became something that circulated through an entire economy, came later, under a different dynasty, in circumstances that combined practical necessity with the administrative reach of a large centralized state. The Song dynasty, which governed China from 960 CE onward, inherited an economy in which bronze coins were the primary medium of exchange, and the supply of bronze was never quite adequate to the scale of commerce that its bustling cities and extensive trade networks required. In certain regions, coin shortages had become a recurring feature of economic life. Merchants in those areas had developed their own workarounds, using private deposit notes issued by wealthy commercial houses to conduct transactions when coin was scarce. These private notes, called jiaozi, functioned in a way broadly similar to the flying money certificates of the Tang period, but had begun circulating more widely within their regions, passing between parties who might never have deposited coins with the issuing house at all. The Song government observed this and made a decision that changed the nature of money in a way that still echoes in every economy on Earth. Around 1023 CE, the government took control of jiaozi production and established dedicated bureaus for the printing and management of paper currency. The state would print the notes, the state would guarantee their value, and the state would, at least initially, limit their circulation to specific regions where they were most needed. The world's first government-issued paper money had come into existence, pressed from carved wood blocks onto sheets of mulberry paper in officially sanctioned workshops, stamped with government seals, and distributed through administrative channels to the regions where coin shortages had made them necessary. A Song dynasty government printing bureau was a particular kind of workshop. Long tables ran the length of the room. Carved wood blocks, each one cut to carry the design and denomination of a specific note, were inked with care and pressed onto paper with an even, controlled pressure that required skill to maintain consistently. The finished notes were set aside to dry, stacked in orderly rows, each one a small rectangle of mulberry fiber paper bearing characters that identified its value and the authority behind it. The ink was specific. The government had worked to develop formulations that would be difficult to replicate, and the paper itself was not the ordinary paper of correspondence or record keeping, but a material chosen for its durability and its resistance to easy imitation. The notes carried a printed warning against counterfeiting. They carried a serial registration that connected each note to its printing batch. They were, in other words, designed from the beginning with a recognition that paper money required protection in a way that metal coin did not, because a coin's value was partly inherent in its metal, while a note's value was entirely a matter of the authority behind it. Undermine the authority, and you had a piece of decorated paper. The Song government understood this, and the printing bureaus operated with a formality appropriate to institutions whose product was, in a meaningful sense, trust given physical form. The circulation of paper money in Song China expanded over the following decades, moving from regional use toward broader application as the system proved workable and the government's administrative infrastructure grew confident in managing it. By the high point of the Song period, paper currency had become a routine feature of commercial life in much of China, used alongside coin rather than instead of it, representing a layer of the economy that had not existed before. The experiment, a layer of the economy that had not existed before, conducted at the scale of a large civilization and sustained over generations, demonstrated something that had not been demonstrated anywhere else at that time, that a piece of paper, backed by a credible authority and accepted by a large enough community of users, could perform the same functions as metal. This demonstration remained largely unknown in Europe for centuries. The knowledge that China had developed paper money reached European travelers through accounts like those of Marco Polo, who described the paper currency of the Mongol rulers with a mixture of genuine interest and unconcealed wonder. But the system it described was so far removed from European monetary practice that it read more like a curiosity than a lesson. European economies continued to operate on metal for a long time after China had been using paper, and when Europe did eventually develop its own paper money, it arrived not through a government decree modeled on Chinese practice, but through a much more local and organic process, growing out of the habits of a particular profession in a particular city. The goldsmiths of medieval Europe occupied an interesting position in the commercial world of their time. They worked with precious metal, which meant they needed to secure it, which meant they had vaults. A goldsmith's vault was, by the standards of the period, a genuinely secure piece of infrastructure. Heavy door, iron fittings, locks that would have been difficult to overcome without attracting considerable attention. This security, which the goldsmiths had built for their own purposes, turned out to be useful to others. Merchants and wealthy individuals who possessed gold or silver coins but were nervous about the hazards of keeping them at home, fire, theft, the various misfortunes that attended storing valuable things in ordinary residences, began approaching goldsmiths with a practical request. They would deposit their coins with the goldsmith, who would record the quantity and issue a written receipt acknowledging the deposit. The goldsmith's vault would hold the metal. The depositor could retrieve it on demand by presenting the receipt. This arrangement was straightforward enough in its original form. A depositor left coins with a goldsmith and held a piece of paper that entitled them to take those coins back. The paper was a record of a transaction, nothing more. But something interesting happened when merchants began to notice that carrying the receipt was easier than retrieving and transporting the coins every time a transaction needed to be settled. If a merchant owed money to another merchant, and that other merchant was willing to accept the goldsmith's receipt instead of the coins themselves, the debt could be settled without either party ever touching metal. The paper had begun to circulate. This was not a deliberate invention. It grew from the accumulation of individual decisions made by people who found the paper more convenient than the alternative. A receipt was lighter than coin. It could be handed over in a moment. It represented a specific documented quantity of metal held in a specific, known location by a person with an established reputation. As long as the goldsmith was trusted, the receipt was as good as the gold, and in some practical respects, it was better because it moved more easily. The goldsmiths noticed this, and the more perceptive among them noticed something further, that depositors rarely came to withdraw their gold all at once. People deposited, and some withdrew, but the total held in the vault tended to remain relatively stable over time, with individual withdrawals offset by new deposits. This meant that a goldsmith who held, say, 1,000 coins on behalf of various depositors could, with some care, issue receipts representing somewhat more than 1,000 coins, because the likelihood that all depositors would demand their coins simultaneously was low. The interest earned on the additional notes issued would compensate the goldsmith for the risk. The goldsmith had become, without any formal declaration, a bank. What these goldsmiths had discovered was the principle underlying fractional reserve banking, the practice of holding only a fraction of deposits as actual reserves while lending or issuing notes against the remainder. It was a practice that made sense in most circumstances and created problems in exceptional ones, and the history of banking since has been in part the history of calibrating where that fraction should sit and what protections should surround it. But at its origin, in the candlelit strong rooms of medieval European goldsmiths, it was simply a practical observation about the behavior of depositors, applied quietly and without fanfare to the business of making money from money. The receipts these goldsmiths issued evolved over time into something more standardized. Instead of a document that named a specific depositor and a specific quantity of coin, goldsmiths began issuing receipts made out to the bearer, meaning that whoever held the piece of paper was entitled to the metal it represented, regardless of who had originally deposited it. Bearer notes could circulate freely. They could change hands repeatedly without any of the intermediate holders needing to visit the goldsmith or conduct any additional paperwork. The note had become, in every meaningful sense, currency. This evolution happened gradually across multiple cities and countries without a single moment of invention. The same logic played out in Amsterdam, in London, in Genoa, and in Hamburg, in the trading cities of the Netherlands, where merchants from across northern Europe converged and needed reliable instruments to settle accounts that spanned enormous geographic distances. The particular forms varied. Some cities established formal banks, backed by civic authority. Others continued to rely on private goldsmith arrangements, but the underlying movement was consistent. The convenience of paper had asserted itself, and once asserted, it did not retreat. In Sweden, in the middle years of the 17th century, a specific problem produced a specific solution that marked an important threshold in European monetary history. Swedish copper coins of the period were extremely large and heavy. The country's abundant copper deposits had led to a monetary system built on copper rather than silver or gold, and a full-sized Swedish copper coin, called a plate money, could weigh several kilograms. Transporting meaningful sums in Swedish copper was not merely inconvenient in the way that Chinese bronze had been inconvenient. It was, in practical terms, nearly impossible for many purposes. A bank called Stockholm's Banco, established by a financier named Johann Palmstroke in 1657, addressed this problem by issuing printed paper notes that holders could exchange for their copper plate money on demand. The notes, called creditive settler, were a genuine innovation in European monetary practice, not handwritten receipts tied to specific deposits, but printed instruments in standardized denominations that could circulate freely and were redeemable for coin at the bank. The Kreditbevis worked well enough at first. Merchants accepted them. Transactions that would have required teams of porters to move the relevant weight in copper could now be settled with a folded note. The bank grew, and with its growth came a temptation that would appear again and again in the history of paper money. The notes circulated so smoothly, and depositors made so few demands for actual copper, that the bank began issuing more notes than it held metal to redeem. The supply of paper outran the supply of the thing the paper promised. When confidence in the bank faltered, and depositors began to present their notes for redemption in larger numbers than expected, Stockholm's Banco could not meet the demand. The bank collapsed. Palmstruck was prosecuted for mismanagement, tried, and sentenced to death, though the sentence was later commuted. The experiment had demonstrated both the practical utility of printed paper currency and the specific way in which that utility could be undone. What came from the failure was more durable than the bank that failed. The Swedish government, recognizing that the problem had been the bank's management rather than the concept itself, established the Riksbank in 1668. The Riksbank was constituted under government authority with a structure designed to prevent the overissuance that had destroyed its predecessor, and it has operated continuously ever since, making it the oldest central bank still functioning in the world. The institution that emerged from the wreckage of the first European banknote experiment has now been operating for more than 3.5 centuries. The folded note, printed carefully and bearing official authority, had found its way into the European economy and would not leave it. Other countries developed their own institutions and their own paper money over the following decades, some of them more carefully managed than Stockholm's Banco, and some of them rather less so, but the basic direction was set. Paper money was a workable instrument. The question was always who issued it, what stood behind it, and how much trust the community of its users was prepared to extend. Across the Atlantic, in the English colonies that stretched along the eastern edge of North America, the same practical pressures that had produced paper money in China and in Sweden were asserting themselves in a very different context. The colonies were chronically short of coin. England did not send silver and gold to its American possessions in quantities adequate to the needs of colonial commerce, and the coins that did arrive had a tendency to flow back out again in payment for imported English goods. The gap between what colonial economies needed and what metal was available produced a recurring shortage that constrained trade and made ordinary business difficult to conduct. Beginning in 1690, individual colonies began printing their own paper money. Massachusetts was first, issuing bills of credit to pay soldiers returning from an expedition against French Canada when the treasury lacked the coin to pay them. The bills promised future redemption in silver, drawn against tax revenues expected in coming years. They were not backed by coin held in a vault, as a goldsmith's receipt was backed by coin, but by the promise of a government to collect taxes in the future and use that revenue to honor the paper it had issued today. This was a meaningful difference from the deposit receipt model. The colonial bills of credit were instruments of public credit, the government borrowing against its own future revenue, rather than warehouse receipts for metal already in hand. Their value rested on the confidence that the issuing colony would in fact collect the taxes it had promised, and would in fact use those revenues to redeem the bills when the time came. That confidence varied considerably from colony to colony and from period to period, and the value of the bills fluctuated accordingly. Some colonies managed their bills of credit with considerable care, issuing quantities calibrated to what their tax revenues could plausibly redeem, and maintaining a reasonably stable value in terms of the goods and silver that could be obtained for them. Others issued more than their revenues justified, and the bills of those colonies lost value relative to silver as their quantity expanded beyond what the economy could absorb. The word depreciation, which would become one of the persistent concerns of American monetary policy for generations, entered the practical vocabulary of colonial commerce through exactly this experience, the slow slide in purchasing power that accompanied overissuance of paper money unsecured by metal. The Continental Congress, during the Revolutionary War, issued paper currency in quantities that the fiscal capacity of the newly independent states could not sustain. The Continental Dollar, as it came to be called, depreciated severely over the course of the war, to the point where the phrase "not worth a continental" entered common speech as an expression of worthlessness. This was not a trivial experience for the people who had relied on the currency, or the leaders who had presided over its collapse, and the memory of it shaped the monetary provisions written into the Constitution and the debates that surrounded the establishment of a national monetary system in the years that followed. The founders who gathered to write the Constitution in 1787 were men who had watched paper money fail in vivid and damaging ways within living memory. The Constitution they produced forbade the states from issuing bills of credit and from making anything other than gold and silver legal tender. The lessons of the Continental had been absorbed into the founding document, and the relationship between paper money and precious metal would remain a contested and complicated feature of American economic life for more than a century and a half afterward. These colonial experiments, for all their difficulties, contributed something real to the history of money. They demonstrated that paper money could function in an economy that lacked the deep commercial infrastructure of Europe, and they generated practical experience with the problems of managing a paper currency, the relationship between supply and confidence, the role of credible backing, the consequences of issuing more than a system could sustain, that informed monetary thinking for generations. The Philadelphia printing offices where colonial bills were produced, their leaf border designs pressed carefully onto freshly cut paper, and the sheets hung on wooden dowels to dry, were the institutional ancestors of the Federal Reserve's Bureau of Engraving and Printing, though the lineage was never direct and the distances involved were enormous. What runs through all of these stories? The Tang merchant with his paper certificate, the Song Printing Bureau with its wood-blocked mulberry paper, the medieval goldsmith writing out a receipt by candlelight for a depositor who would trade it away the following morning, the Swedish credit stellar that moved copper by proxy, the colonial bills of credit backed by the promise of future taxes, is the same slow realization arrived at independently in different places and at different times that the thing money is made of matters much less than what stands behind it. The metal in a coin contributed to its value, but it was never the whole of it. The paper in a note contributed nothing to its value except its portability. What made any of these things worth accepting in exchange for goods and labor and time was always and only the confidence that the next person would accept them too. That confidence, once extended, turns out to be remarkably durable. It persists through ordinary conditions and through difficult ones. It bends under pressure, but rarely breaks entirely, because the alternative, a world in which no commonly accepted medium of exchange exists, is one that people will work very hard to avoid. The willingness to accept a piece of paper, or a clay tablet, or a stamped receipt from a goldsmith whose vault one has never personally inspected, rests on a foundation that is social before it is economic. It is an agreement, mostly unspoken, maintained by habit and by the practical utility of maintaining it. A freshly printed colonial bill of credit, held up to the window light of a Philadelphia printing house, reveals something in that moment of inspection. The leaf border pattern, printed from a design that Benjamin Franklin had helped develop specifically to make counterfeiting difficult, shows its veining in clear detail against the paper. The ink is still sharp. The denomination is legible. Someone will accept this piece of paper in exchange for something real: cloth, food, labor, a service, not because the paper has any intrinsic value, but because enough other people have already agreed to accept it. And their agreement has made it real in the only way that money ever becomes real: the smell of fresh ink in that printing house, the crispness of the leaf border against the light, the slight waxy feel of the printed surface. These are the physical particulars of an object that represents something entirely abstract. The agreement is invisible. The trust is invisible. Only the paper can be touched, and what the paper actually is considered on its own terms without the agreement that surrounds it is not very much at all. That is the most persistent fact about paper money. From the first flying money certificates folded into the coats of Tang Dynasty merchants to every note printed in every country in every subsequent century, the paper is always the least important part. What matters is the long chain of individual decisions to accept it, each one made in the reasonable expectation that the chain will continue, that the person after this one will accept what the person before this one accepted, and that the whole arrangement, sustained by nothing more substantial than collective willingness, will hold together for another day. And it does hold together. It has held together in various forms and with various disruptions across a span of more than 1,000 years since a Tang Dynasty merchant first tucked a paper certificate into his coat rather than load a chest of bronze onto a mule. The arrangement has changed its form repeatedly. It has passed through the hands of private merchants, centralized governments, goldsmith bankers, colonial printing houses, and national treasuries. It has been expressed in woodblock print on mulberry fiber, and in copperplate engraving on cotton paper, and in dozens of other forms between and after those. But the thing itself, the agreement, held between enough people that the paper among them is worth something, has endured through all of it. In the window light of a Philadelphia printing house, the leaf veins in the border of a newly printed bill of credit are clear and fine and precisely rendered, each one placed there with the specific intention of making the note trustworthy enough to spend. The ink will dry. The note will leave this room and enter the world, changing hands in ways no one in this printing house can foresee, traveling distances its maker cannot predict, representing a value it does not intrinsically possess, but that the long human agreement around it has made as real as anything else in the morning air outside the window. A bank clerk in London, sometime in the middle of the 19th century, opens a heavy leather ledger on a counting desk and begins to record the morning's transactions in a neat sloping hand. The room around him is quiet. The floor is stone. The walls are thick enough that the noise of the street outside arrives only as a distant, muffled movement of air, barely distinguishable from silence. He writes a figure in pounds sterling, draws a careful line beneath it, and notes in the adjacent column the date and the name of the account holder. The figure on the page represents a specific amount of gold, not a promise of gold, not a claim on gold at some future date, but gold in the physical sense, a particular weight of the metal sitting in a vault somewhere beneath the floors of this building, measured and accounted for, its presence underwriting the number inked onto the page above it. This is what a gold standard economy feels like from the inside on an ordinary morning. Nothing dramatic is happening. The clerk turns the page. The ledger fills. The gold stays where it is. The gold standard was, at its most fundamental level, a set of rules that tied the supply of money to the supply of a specific physical substance. In Britain, where the system was formally adopted in 1821, every pound note in circulation corresponded to a fixed quantity of gold held in reserve. The money supply could not expand beyond the gold available to back it. That constraint shaped everything: the pace at which banks could lend, the rate at which economies could grow, the degree to which governments could spend beyond their means. The system felt solid because, in a literal sense, it was somewhere beneath the floor. The weight of metal made the numbers on the page real. Most of the major industrialized nations had joined this arrangement by the close of the 19th century. By then, a merchant in Hamburg, settling a bill with a counterpart in Buenos Aires or Bombay, could reasonably expect that both their currencies referenced the same physical substance at roughly comparable values. The metal grounded the transaction. It made the numbers on two different pieces of paper from two different countries into something commensurate, something that pointed toward the same material fact. This was not a new idea. The relationship between money and precious metal is considerably older than any formal standard, older than any central bank, older in fact than most of the institutions that eventually codified it. Long before British clerks were filling leather ledgers with figures denominated in gold, the ancient world had already worked out that certain metals had an almost unique suitability for the business of exchange. They did not rot. They did not dissolve in water. They were scarce enough to hold value, but workable enough to be shaped, and they could be divided precisely and weighed, which meant they could carry a number, a specific quantity, with an accuracy that grain, shells, or bolts of cloth could only approximate. Silver, in the ancient world, was in many respects more important than gold. It was more available, easier to mine in workable quantities, and its properties made it the foundation of the first true monetary networks of the Mediterranean world. An Athenian silver coin struck in the 5th century before the Common Era, bearing on one side the helmeted profile of the goddess Athena, and on the other her sacred owl, was the closest thing the ancient world produced to an international reserve currency. The coin was called the tetradrachm because it was worth 4 drachmas, and it moved through the ancient Mediterranean not because Athens compelled anyone to accept it, but because everyone had decided, independently and through accumulated experience, that it was worth accepting. A Phoenician merchant in ancient Alexandria, examining one of these coins across a market counter, would turn it once between his fingers. The owl would catch the light. He would nod and complete the transaction. He did not need a scale. He had seen enough of these coins to know their weight. He trusted the silver content, not because anyone had told him to, but because the consistent quality of Athenian coinage had been reliable across enough transactions, across enough decades, that trust had simply accumulated around it. The coin's reputation was its infrastructure. The Athenian tetradrachm circulated from Egypt to Persia. It was found in hordes from Spain to Afghanistan. Its owl design was widely copied by other cities and kingdoms who recognized that the symbol had value beyond the metal it was stamped into, that the image itself communicated something about weight and purity that saved time and reduced risk. When Athens was producing these coins at the height of its power, it was drawing on rich silver deposits in the mines at Laurion in the south of Attica, worked by tens of thousands of people in conditions that the ancient historical record describes with considerable frankness, though without the evaluative language a modern account might use. The silver came out of the earth. It was refined and struck. The coin spread outward across the known world in every ship that left the harbor. Many centuries later, a very different silver coin would do something the Athenian tetradrachm had never quite managed. It would become the first currency to circulate continuously on every inhabited continent on Earth. The Spanish piece of 8, minted from silver discovered in the mountains of what is now Bolivia, was for roughly 2 centuries the closest thing to a universal coin the world had ever known. It moved from the Americas to Spain, from Spain to the ports of West Africa, from West Africa across the Indian Ocean to the trading houses of Goa and the great markets of Canton. In the archives of the Ming and Qing dynasties, there are records of Spanish coins arriving in Chinese ports by the ton, traded for silk and porcelain, and then melted down and restruck with local weights and marks. The coin that began its life in a Bolivian mine shaft ended its journey somewhere it had never been imagined, absorbed into economies it had not been designed to serve. The discovery that made all of this possible happened in the year 1545, in the high, thin air of the Bolivian Altiplano, at a place called Cerro Rico, in Spanish, the Rich Mountain. The story that most accounts agree on is that indigenous workers discovered an extraordinarily rich vein of silver ore in the mountain's interior. What followed was one of the most concentrated and sustained extractions of precious metal in recorded history. Cerro Rico rises above the city of Potosi at an altitude that makes every breath a small effort. The mountain is steep-sided and reddish-brown, its surface broken by thousands of mine shafts cut into it across 3 centuries of continuous operation. At its peak, in the late 16th and early 17th centuries, Potosi was one of the largest cities in the world. Workers came from across the region to labor in the mountain's dark interior passages. The ore they extracted was carried out and down to smelting furnaces in the city below, where it was reduced to raw silver and eventually cast into bars or struck into coins in the mint that the Spanish crown established to process the output. The estimates that historians have assembled suggest that the mines of Cerro Rico produced something close to half of all silver mined globally across the 16th and 17th centuries. This was not simply a large economic event, it was a geological event reflected in human commerce. The mountain's silver entered the global economy at such volume and such speed that it disrupted price levels across Europe and Asia in ways that took economists several centuries to fully understand. The metal that underpinned the monetary systems of the ancient world had for a long time been a relatively stable foundation. The discovery of Cerro Rico changed the rate at which that foundation could be expanded, and the world's monetary arrangements shifted accordingly. The Spanish piece of 8 that eventually traveled from that mountain to the markets of Canton was, in a sense, the mountain itself, reduced and refined, and stamped with a cross and shield, made portable enough to cross an ocean. The mint workers who handled the freshly struck coins in the 16th century would hold one up to the light after it came from the die, still warm, still carrying the faint smell of hot metal, and examine the design for any flaw or inconsistency. A single piece of 8, well struck and accurately weighted, might travel to China, to England, to the ports of West Africa, through a dozen pairs of hands across as many years, before it disappeared into a national treasury or a private hoard somewhere and stopped moving entirely. The material this coin was made from, refined silver, dense and white and reflective, was the same material that had moved through the ancient Mediterranean in Athenian coins a millennium before. Different stamps, different political arrangements, different names and different markets, but the same metal with the same fundamental qualities. It did not corrode, it could be precisely divided, and it could be stamped with a mark that made its quantity legible to a stranger at a glance. The metal and its properties were the constant. The human arrangements built around it changed continuously. By the early 20th century, those arrangements had evolved into something considerably more complex than a market trader examining a coin between two fingers. The gold standard had become a formal international system with central banks, exchange rate commitments, and elaborate mechanisms for settling imbalances between nations. The system functioned with interruptions and adjustments until the First World War broke something in its underlying logic. Nations at war spent more than their gold reserves would allow. They suspended convertibility. The metal was still there, but the promise had been temporarily set aside, and the temporary proved difficult to restore in precisely the same form. The arrangement that replaced it, or tried to, took shape in the summer of 1944 in a hotel in the mountains of New Hampshire, at a point in the war when the outcome was becoming visible but had not yet arrived. The Mount Washington Hotel stands in the White Mountains, its white clapboard exterior set against a backdrop of forested slopes that in late July are deep green and still. The building is large and slightly grand in the manner of 19th century resort hotels, with wide verandas and a long facade facing the valley. In early July of 1944, it was full of people in suits, carrying leather briefcases and rolls of documents. Representatives from 44 nations had gathered at Bretton Woods, New Hampshire, to discuss what the international monetary system should look like after the war ended. The conference lasted 3 weeks. The delegates worked in ballrooms rearranged as conference halls, at long tables covered in cloth, under the specific pressure of people who knew that what they decided would shape the economic life of the post-war world for decades. The arrangements they reached were intricate, but the central mechanism was relatively straightforward. The United States dollar would be pegged to gold at a fixed rate of $35 per troy ounce. Every other participating currency would be pegged to the dollar. The entire system thus retained its connection to physical gold, but that connection now passed through a single currency, the dollar, rather than being held independently by each nation. 2 new institutions were created at Bretton Woods to manage this system: the International Monetary Fund, which would provide short-term financial assistance to countries experiencing balance of payments difficulties, and what eventually became the World Bank, initially established to support reconstruction in war-damaged economies. These institutions remain in operation today, though the monetary system they were built to support has changed almost entirely since they were founded. The Bretton Woods system functioned with reasonable stability for roughly a quarter century. The dollar held its value. Other currencies held theirs relative to the dollar. International trade expanded. The physical gold at the center of the system, held largely at Fort Knox and at the Federal Reserve Bank of New York, remained the point to which the whole arrangement ultimately referenced itself, the distant material anchor that gave the numbers their ground. The pressure that eventually ended this arrangement built across the 1960s as the United States ran persistent deficits, partly from the costs of the Vietnam War and partly from domestic spending programs, and other nations accumulated large dollar reserves. Under the rules of Bretton Woods, those reserves were convertible into gold at the fixed rate. France, under President de Gaulle, actually exercised this right, sending ships to collect gold from the Federal Reserve in exchange for dollar reserves. The gold in the vaults was moving. The ratio of gold to outstanding dollar claims was changing. The promise that every dollar could be converted to gold at $35 an ounce was becoming, in practical terms, harder to maintain. By the summer of 1971, the mathematics had reached a point where the policy decision could no longer be deferred. On the evening of August 15, 1971, a Sunday, President Richard Nixon appeared on American television to address the nation about the economy. The room in which an ordinary household might have watched this broadcast was probably lit only by the television screen, the rest of the room dim and still. Nixon spoke for several minutes, and among the measures he announced was the immediate suspension of the dollar's convertibility into gold. From that moment forward, foreign governments would no longer be able to exchange their dollar reserves for metal at the Federal Reserve. The fixed rate of $35 per ounce, established at Bretton Woods 27 years earlier, would cease to apply. This announcement, delivered in the measured tones of a policy statement, ended something that had been true in one form or another for as long as governments had issued currency backed by metal. From the electrum coins of ancient Lydia, to the silver denarii of Rome, to the gold-backed pounds of Victorian Britain, to the Bretton Woods dollar, the money in circulation had always, in some form, pointed toward a physical substance, a weight, a quantity, something that existed in the material world and could, in principle, be produced and examined and weighed. After August 15th, 1971, the world's major currencies no longer had that quality. Their value would henceforth rest on other things: government credibility, market expectations, institutional trust, the shared agreement of the economies that used them. The word economists use for this kind of money, money backed not by metal but by institutional authority, is fiat, from the Latin word for decree. The dollar, after 1971, was worth what the collective arrangements of the United States government and the global economy said it was worth. The same was true of every other major currency. The metal had become optional. This was not immediately obvious on August 16, 1971. A dollar bill the morning after Nixon's address looked exactly like a dollar bill the morning before. The cotton and linen fiber was the same. The engraved green numerals on the paper were the same. The notes still passed across shop counters in exchange for goods. The numbers in bank ledgers still functioned as they had the previous day. The change that had occurred was entirely in the relationship between the physical object and the claim it represented, a relationship that had never been visible on the face of the note anyway, only known, assumed, and occasionally tested. What had changed was the answer to a question that most people never think to ask when they hold a banknote. The question is, what in the end is this redeemable for? Before 1971, there was an answer that pointed toward a specific substance, in a specific quantity, in a specific location. After 1971, the answer was different. It was longer, more abstract, and rested on a set of institutional and social arrangements rather than on a bar of metal in a vault. The note was still worth something. It was just worth it for different reasons, and those reasons were harder to hold in the hand. The transition from metal-backed money to fiat money happened at different times and in different ways in different countries, and its full implications took years to become clear. In the immediate term, the dollar's exchange rate with other currencies, which had been fixed under Bretton Woods, was allowed to float. Gold's price in dollar terms, which had been fixed at $35 per ounce for decades, rose rapidly in the free market. Within a decade, an ounce of gold was worth more than $500. The physical substance had not changed. What had changed was its relationship to the paper money that had once been fixed to it. The mountain of Cerro Rico, meanwhile, had continued to be mined long after the great silver boom of the 16th century had passed. By the 20th century, the richest veins had been largely exhausted, but mining continued in its upper reaches, extracting silver and other metals from the remaining ore. The mountain itself, seen from the plains below Potosi, is visibly diminished compared to historical accounts of its original height. Centuries of extraction have taken measurable quantities of it away, gram by gram, ton by ton, distributed across the world's economies in the form of coins and bars and industrial metal. The mountain stands in the thin, cold air of the Altiplano, its flanks still marked by the openings of thousands of shafts cut into it across 300 years of continuous work. The oldest of them now dark and silent, their interior timbers long since rotted, their openings half collapsed with time. From a certain distance, on a clear day, the pattern of shafts across the mountain's surface is visible as a kind of texture, a regular repeated marking that records the accumulated work of enormous numbers of people across an enormous span of time, each passage cut to follow a vein of silver, downward or sideways into the rock, each one a record of a specific decision made at a specific depth. The shafts go in and go down, and eventually stop at the points where the ore ran out, or the rock became too difficult, or the machinery could no longer reach. The mountain holds all of them, the old and the recent, in the same long, patient stone. The silver that came out of those shafts moved across the world as currency. It was minted in Potosi, and in Mexico, and in Lima, and it traveled by sea to Spain, and by galleon to the Philippines, and then across the South China Sea to Canton, and it circulated through Chinese markets, and European markets, and African markets in such quantities that it became for a period the common language of global commerce. A merchant in Seville, and a merchant in Goa, and a merchant in Canton could all, in the late 16th century, hold the same coin, the same weight of Bolivian silver, struck with the same Spanish cross and shield, and recognize it for what it was without translation. The metal spoke plainly, without needing to be explained. Gold worked differently. Gold was scarcer, worth more by weight, harder to acquire in quantity. In the economies that accumulated it and eventually formalized its relationship to paper money, it functioned less as a medium of daily exchange and more as a reserve, a foundation, a material guarantee underlying the numbers written on paper. In a gold standard economy, the gold in a central bank's vault was not circulating. It was sitting still, doing its work simply by existing in a specific quantity, in a specific place, its weight guaranteeing the value of the notes that moved on its behalf. There is something specific about that image, the gold sitting immobile in a vault, while the paper representing it circulates freely, that captures something essential about how monetary systems work. The thing itself stays still. What moves is the claim. The metal is the anchor. The note is the ship that travels to the end of its chain and back. For as long as the anchor holds, the ship stays within reach of a point fixed in the material world. After 1971, the anchor was lifted. The ship still moves. It simply moves now in water, where the bottom is not reachable. The men who met at Bretton Woods in the summer of 1944 could not have fully anticipated the moment when the system they were building would end. They were designing for the post-war world as they could imagine it from the vantage point of 1944, drawing on the lessons of the interwar monetary disasters and the gold standard's inflexibilities. The architect of the British delegation's proposals, the economist John Maynard Keynes, had hoped for a more radical arrangement, a new international currency he called the Bancor, which would have replaced the dollar at the center of the system and removed the advantage that came from having one nation's currency serve as the global reserve. His proposals were not adopted. The American delegation, representing the world's dominant economy and largest gold reserves, had less reason to want the system's center moved away from Washington. The arrangement that emerged was the one that served the existing balance of power, as these arrangements generally do. Keynes died in April of 1946, before the institutions created at Bretton Woods were fully operational. The system he had helped shape though not in the form he had wanted, functioned for roughly the next quarter century. The world he imagined, with a genuinely neutral international currency at its center, remains unbuilt. What exists instead is the system that replaced Bretton Woods after 1971, a floating exchange rate regime in which the dollar, still dominant through institutional inertia and the global scale of American financial markets, remains the closest thing to a reserve currency the world has, even without the gold backing that once gave it that status. The gold remains. Most of the gold ever mined in human history is still in existence because the metal does not corrode and was rarely destroyed, only moved. It sits in central bank vaults, in jewelry, in electronic components, in the reserves of institutions around the world. The total amount of gold ever mined by all of human civilization, according to the estimates that geologists and economists have produced, would fill roughly 3.5 Olympic swimming pools, all of it. Every coin struck in Lydia and Rome and Athens, every bar smelted from every mine from South Africa to Nevada, every ounce ever pulled from the earth across the full span of human history, would fit in a space smaller than most people imagine. Silver's total is larger because silver is more abundant and has been mined in greater quantities. The silver from Cerro Rico alone ran to hundreds of millions of ounces across its operational life. But the principle is the same. These were finite physical substances. The economies built on them were in some fundamental sense bounded by that finitude. The transition to fiat money was, among other things, a transition away from that bound into a monetary world where the supply of money is determined by policy rather than geology, by decisions rather than deposits, by the credibility of institutions rather than the weight of metal. Whether that transition was a liberation or a loss depends on what one was hoping to get from the anchor. The people who favored the gold standard valued its constraint, its resistance to political manipulation, its grounding in something that governments could not simply decide to produce more of. The people who argued against it valued the flexibility it denied, the ability to expand the money supply in response to economic need, to cut interest rates in a recession without worrying about the gold reserves, to allow the monetary system to be responsive rather than fixed. Both sets of concerns were reasonable. The debate between them runs through the economic history of the 20th century with a persistence that suggests no fully satisfying resolution has been reached. The stone floor of that London bank clerk's office, the ledger open on the desk, the figure in pounds corresponding to a weight of gold below, that is one world's answer to the question of what money is. A specific object in a specific place, present and verifiable, its existence making the number on the page factual rather than merely claimed. The television screen glowing in a quiet room on August 15th, 1971, the measured voice announcing a suspension that is the threshold between that world and the one that followed it. Cerro Rico still stands in the cold, thin air above Potosi. The mountain's profile is visible for many miles across the flat altiplano, its distinctive cone shape recognizable against the sky. The shafts cut into its flanks over 3 centuries of mining have left it measurably smaller than it was in 1545, when the first rich veins of silver were discovered, and the long work of extraction began. The centuries are written into the mountain in the pattern of those openings, each one a record of labor and material in time, the old ones dark and silent now, their timbers long since collapsed, their ore long since dispersed across the world in the form of coins and bars and objects that carried monetary weight for a generation or a century before being melted down. Restruck, reformed, and moved on, the silver from those shafts traveled far. It moved through the economies of empires that no longer exist, was held in the hands of people whose names were never recorded, passed across counting tables in ports from Seville to Canton to Calcutta, and was gradually absorbed into the accumulated reserves and daily commerce of a world that eventually decided it no longer needed the physical metal to serve as the foundation of its monetary arrangements. The mountain remained, the silver scattered. The arrangement that had depended on the metal continued in changed form without it. The Bretton Woods delegates in their white clapboard hotel in the New Hampshire mountains in the summer of 1944 were working, in a sense, on the last major redesign of a system that still had metal at its center. They flew home, and the system they built held for 27 years. The mountain above Potosi had been providing silver to world commerce for close to 4 centuries by the time Nixon spoke on television. The world's appetite for the metal that underpinned so much of global exchange across so many centuries had been, by any measure, very large, large enough to hollow out a mountain, large enough to move the price levels of continents, large enough to build fleets and cities and institutions that lasted for generations. The mountain absorbed all of it quietly. It stands in the cold Bolivian air, marked by everything that was taken from it, its remaining mass of rock and residual ore, patient and still in the long, thin light of altitude, carrying in its shape the record of a world's long and consuming interest in what lay inside. A newly struck Roman denarius is a small thing. It sits in the palm with the density of something made to last, not heavy the way a stone is heavy, but settled, purposeful, the weight of a precise quantity of silver pressed into a shape that was meant to carry meaning across an empire. Fresh from the die, it still held warmth. The relief around the portrait was sharp enough to feel with a fingertip, the lines of the emperor's laurel wreath distinct and fine, the lettering around the edge crisp in a way it would not remain after passing through 1,000 hands and 1,000 transactions over the years ahead. In a small workshop near the Roman Forum, lit by oil lamps and the glow from a small furnace used to heat the blanks before striking, the smell in the room was the specific dry metallic smell of hot silver cooling on a board. The moneyer who lifted it from the die board and set it with the others knew, in the way that craftsmen know the quality of their own work, that this particular coin had come out well. The Roman denarius had been in production for roughly 4 centuries by the time coin-making workshops like that one had refined their methods to a reliable art. The coin was introduced around 211 BCE during the Second Punic War, when Rome was engaged in one of the most costly military struggles it had ever faced and needed a monetary instrument capable of funding armies operating simultaneously across multiple theaters of war. A single standardized silver coin, struck to a reliable weight and fineness, could move through a military supply chain far more smoothly than a patchwork of regional currencies and weighed metal. The denarius became that instrument. Its name passed into the daily language of commerce so thoroughly that it survives in modern words for money. The Spanish word dinero and the Italian denaro both carry it forward. Worn smooth by time, the way a well-handled coin wears smooth. The letters changed, but the root's still there, beneath the surface. The process by which that coin was made would be recognizable, at least in its basic movements, to anyone who had ever watched a craftsman work with a die and a hammer. A metal blank, already cut to the approximate correct weight, and heated until it was just soft enough to take an impression cleanly, was set on a lower die fixed into an anvil. The lower die was engraved in intaglio, cut down into the metal so that the design it carried would press up into the blank as a raised relief. A second die held above the blank and engraved with the obverse design was positioned carefully and then struck once with a hammer. In skilled hands, one clean blow was enough. The two dies and the blank came together for a fraction of a second. The metal flowed into the engraved recesses, and the coin emerged fully formed, a portrait on one face, a symbol or figure on the other, the design readable and sharp if the craftsman had done his work correctly. The workers who performed this operation were called moneyers, and what they possessed was less a mechanical skill than a calibrated physical knowledge of how metal behaved under force. This hammering method, sometimes called hand striking or the hammer coinage method, was the foundation of coin production across Europe, the Mediterranean world, and the Near East for approximately 2,000 years. 2,000 years is a long time for any technology to hold its ground, essentially unchanged, and the reasons it did come down largely to adequacy. The method worked. It produced functional coins with sufficient reliability that no pressing improvement was needed, and in economies where the volume of coinage required was manageable, the throughput of skilled moneyers working in organized workshops met the demand. The coins varied from die to die, from strike to strike, from workshop to workshop, in ways that would be unacceptable by modern standards. A collection of denarii from the same reign might show portraits that look in small but definite ways like different people. The roundness of the blanks varied, edge details were sometimes weak, but within the tolerances that trade and commerce required, the coins were recognizable, consistent in their weight, and trusted, and for a very long time that was what mattered. The screw press arrived in European coin production in the 1550s, and it arrived as a solution to a problem that had been accumulating slowly under the surface of the hand-hammering tradition. The problem was not volume, exactly, though a screw press could produce coins at a greater rate than a team of moneyers working with hammers. The problem was uniformity, the kind of precise, repeatable uniformity that handwork, however skilled, cannot quite sustain across thousands of strikes. A mechanically applied force, controlled by the geometry of a screw driven downward through a fixed path, pressed each blank with the same pressure, in the same orientation, through the same distance. The coins that emerged were rounder, more consistent in diameter, more uniform in the depth and clarity of the design. The Paris Mint introduced the technology in the 1550s, and the improvement in coin quality was visible and immediate. The workers whose livelihoods rested on the old methods did not welcome this. Moneyers had spent years, in some cases their entire working lives, developing the physical knowledge that made them valuable. The hand-striking craft was not something any person could simply step into. It required a trained eye for the condition of a blank, a practiced sense of where to position the upper die, a feel for how hard to strike and at what angle. The screw press did not require any of that. It required different knowledge, different skills, but not the accumulated embodied expertise that had made the moneyer's craft a craft rather than a task. Resistance to the new machinery was, under those circumstances, a rational response to a real economic threat, and the transition from hammered to milled coinage in the decades that followed happened unevenly, at different rates in different places, sometimes delayed by institutional preference for established methods, and sometimes accelerated by the clear evidence of quality that the mechanical press produced. What the screw press produced, in the long run, was a new kind of coin, one whose very consistency was part of its value, a coin that was always the same size, always the same thickness, always struck with the same depth of relief, was a coin that could be checked instantly for tampering. Older hammered coins, with their variable edges and irregular shapes, were easier to clip, to shave small amounts of metal from the edge, and pass the slightly lighter coin as if it were full weight. The uniformity of milled coinage made clipping obvious, and later innovations, including the milled edge, the reeded or lettered rim that became standard on many coins, made it more obvious still. The precision that began as a craft improvement became, over time, a security feature. Isaac Newton spent the later years of his career not at Cambridge working on physics, but at the Tower of London working on coins. He was appointed Warden of the Royal Mint in 1696 and became its master in 1699, and the work he took on there was administrative and investigative rather than theoretical. The Royal Mint at that time occupied a complex of buildings within the tower's outer ward, and Newton's role brought him into close contact with the physical business of coin production. The furnaces, the rolling mills, the presses, the assay processes by which the metal content of each batch was tested. He could be found reviewing sample coins under a magnifying lens, making careful notes about the consistency of edge milling, comparing the dimensions of newly struck pieces against the standards the mint was required to meet. The precision he brought to this work was the same precision he had brought to everything else, but the object of it was very different, not the motion of planets, but the roundness and weight of a shilling. Newton's tenure at the Mint coincided with what was called the Great Recoinage, a nationwide effort to replace a large proportion of English coinage that had become severely degraded through decades of clipping and wear. The old hammered silver coins still circulating in the 1690s were in some cases so worn and so heavily clipped that their weight had fallen to a fraction of their face value. The problem this created for trade was not trivial. A currency that nobody trusted to contain the metal it was supposed to contain undermined every transaction it passed through, adding the friction of doubt to exchanges that required confidence to function efficiently. The recoinage replaced those worn pieces with milled silver struck to consistent standards, and Newton's careful attention to quality control was part of ensuring that what came out of the mint was what it was supposed to be. He took the work seriously in the same way he took every intellectual problem seriously, not as administration, but as a question that required a correct answer. The Royal Mint had been producing coins for English monarchs for a very long time before Newton arrived to oversee it. Its origins reached back to approximately 886 CE in the reign of King Alfred the Great, making it one of the oldest continuously operating institutions in the English-speaking world. Alfred's Mint was not the first coin-producing workshop to operate in Britain. Roman mints had operated there during the period of Roman administration, but it was the foundation of what became a continuous royal monopoly on coinage that extended across more than 1,000 years. The mint operated in various locations across its early history, following the movements of royal authority and administration before settling into the Tower of London during the medieval period. There, within the walls that also housed a prison, an armory, the crown jewels, and a menagerie, coins were struck for generation after generation of English and later British monarchs. The Tower of London location lasted for centuries, so long that the Mint and the Tower became inseparable in the public mind. The arrangement ended in 1809 when the Mint relocated from the Tower to a purpose-built facility on nearby Tower Hill, a move motivated partly by the need for more space and partly by the new industrial-scale machinery that the Napoleonic Wars era demand for coinage had made necessary. The Tower Hill facility served for more than a century and a half before the Mint moved again, this time considerably farther, to L'Entresant in South Wales in 1968, where it still operates. The Welsh facility was built for modern production volumes and modern automated processes, and the move was pragmatic: space, modern infrastructure, room to expand. What it carried with it, beyond the machinery and the staff and the accumulated institutional knowledge of 1,000 years of coin production, was an unbroken operational thread back to the workshops of Alfred the Great's reign. Today, the Royal Mint produces coins not only for the United Kingdom, but for more than 60 other countries, along with commemorative and collector pieces and medals. The scale of production in the L'Entresant facility is difficult to picture from the vantage point of a moneyer's workshop of 2,000 years ago. Automated presses drive through enormous numbers of coin blanks in a single production run, each press striking coins at speeds that would have seemed like conjuring. But the basic physical act at the center of the process, a metal blank placed between two engraved dies and pressed with sufficient force to transfer the design, is recognizably the same act that produced the first hammered coins. The mechanism has changed beyond recognition. The materials have changed. The scale has changed. The principle has not. The United States Mint came into existence considerably later than its counterpart in Britain, but when it did, it came into existence with unusual specificity. The Coinage Act of 1792 established the mint in Philadelphia, which was at that time the young country's capital and largest city, and the act was precise in ways that reflected both the new government's careful attention to monetary credibility and the hard experience of what happened when currency was not trustworthy. The act specified the exact metallic content of each coin denomination, the precise weight of gold, silver, or copper that each piece was required to contain, and it established a particular penalty for those who debased the coinage. Debasement, in the Act's terms, was not a minor administrative infraction. It was made a capital offense. The punishment reflected the severity with which the framers of the Act understood monetary fraud, to threaten the confidence on which the new national currency depended. The Philadelphia Mint was a modest brick building on 7th Street in its early years, with a character more in keeping with a small workshop than with the monumental financial institutions the 19th century would later build. Workers there weighed coin blanks on brass balance scales, fed them into screw presses, not entirely different from the kind introduced in Paris 2 centuries earlier, and accumulated the finished coins in wooden trays beside the machines. The cents, half dollars, and silver dollars that came out of those presses in the 1790s were among the first tangible material evidence that the new national monetary system was real and functional, that the country's ambitions regarding its own currency had been translated into actual metal objects that could be held, counted, and traded. Demand for coins grew faster than Philadelphia alone could supply. Gold was discovered in Georgia and North Carolina in the 1820s and 1830s, creating a need for processing facilities that could convert the newly mined metal into currency closer to where it was extracted, rather than sending it all the way to Philadelphia for minting. In 1838, branch mints opened in 3 new locations: New Orleans, Louisiana, Dahlonega, Georgia, and Charlotte, North Carolina. The New Orleans facility was positioned to handle silver arriving through the Mississippi River trade network, as well as gold from the interior. The Dahlonega and Charlotte mints were smaller, oriented almost entirely toward gold coinage from the nearby Appalachian mines. Each of these facilities operated under the same metallic standards established by the 1792 Act. Their coins produced to the same specifications as those made in Philadelphia, identifiable only by the small mint mark pressed into the design, a tiny letter that told anyone who looked closely where the coin had been made. The coins that came out of Dahlonega and Charlotte during their years of operation were not produced in vast numbers, and surviving examples from those mints are correspondingly rare today. But while they operated, They perform the same function that all coins in a well-functioning monetary system perform. They were portable, durable, standardized carriers of established value that could pass between strangers in a market transaction without requiring either party to know or trust the other personally. That function was the same function the Roman denarius had performed, and the same function the Athenian silver tetradrachm had performed before it, and the same function that rough bronze pieces, struck in workshops across the ancient world, had performed in the earliest days of metal coinage. The specific metal changed, the portraits and symbols changed, the workshops and the machines changed. What persisted was the idea of a standardized, authenticated object whose value was fixed by authority and whose authenticity could be checked, at least approximately, by a glance or a fingertip. The process of engraving a coin die, the master tool from which thousands of individual coins would ultimately be struck, was one of the most demanding forms of miniature sculpture in practical use anywhere in the world. A die engraver working in the 18th or 19th century began with a piece of hardened steel and a set of gravers, small cutting tools with differently shaped ends, and worked in reverse, cutting into the steel the image that would appear in raised relief on the finished coin. Everything had to be considered in terms of its opposite. What was cut away from the die would project outward from the coin. What was left standing on the die would sink into the coin's face. The scale demanded steadiness. A portrait head on a coin the size of a quarter occupied roughly 8 or 9 millimeters of space, and within that space, the engraver was expected to render something that read as a recognizable face, with structure and shadow, and something approaching expression, using nothing but the pressure of a small steel tool on hardened metal. The engravers who became known for their work in this field left their marks on the coins that circulated through entire economies for decades. The designs they cut into steel, or in earlier periods into stone or bronze, were reproduced millions of times and passed through millions of hands. A good coin portrait was one that held up under that repetition, that remained legible and dignified after the die had been used for thousands of strikes and the coin itself had passed through years of circulation. It was a form of art with the most demanding possible practical test, not the appreciation of a viewer in a gallery, but the durability of use. The edge of a coin, that thin band of metal visible when you look at a coin from the side, accumulated its own history of technical development. Early hammered coins had no particular edge treatment at all. The edge was simply where the metal of the blank ended, irregular and uncontrolled. Milled coinage introduced the possibility of adding texture to the edge as part of the striking process, and this possibility was quickly recognized as valuable. A reeded edge, the pattern of parallel ridges running around the circumference of many coins, was difficult to apply smoothly after a coin had been struck and made clipping or shaving the edge immediately visible. Some coins received a lettered edge instead, with words or numbers impressed around the circumference, serving both as a design element and as a tampering deterrent. The edge of a coin, which appears to a casual glance to be simply the coin's thickness made visible, was in practice one of the most carefully considered elements of its design. Coin blanks, before they were struck, went through a series of preparatory steps that varied somewhat from era to era and mint to mint, but generally involved annealing, heating the metal to soften it slightly and relieve internal stresses from cutting, followed by cleaning to remove the surface oxides that annealing created, and then upsetting, passing the blank through a machine that raised a small rim around its edge before striking. The upset rim served as a reservoir of metal during the strike, flowing outward to fill the engraved edges of the die design. Without it, the high-relief details at the periphery of a coin design were the first features to be weakly struck, producing pieces where the central portrait was crisp, but the surrounding details were flat and indistinct. The upset rim was a technical refinement that improved quality across the entire coin face, a small adjustment in preparation that had significant effects on the finished product. A person who has handled a lot of coins, worked with them regularly, sorted them, counted them, examined them, develops a set of reflexive judgments that operate below conscious attention. Weight, temperature, edge feel, the sound a coin makes when it strikes a surface. These sensations accumulate into a tacit knowledge that allows an experienced handler to notice, without thinking about it explicitly, when something about a coin is not quite right. A coin that is too light for its size, an edge that is too smooth, a design that is slightly blurred in a way that suggests the die was worn or the blank was not properly prepared. This kind of embodied expertise was essential in economies where coins of different origins, different ages, and different levels of wear circulated simultaneously, and where the ability to quickly assess a coin's authenticity and metallic content was a practical commercial skill rather than a specialist interest. The mint mark, that small letter or symbol pressed into a coin's design to indicate where it was produced, provided one layer of accountability in a distributed minting system. When multiple facilities operated under a single monetary authority, the mint mark allowed any problem with a particular batch of coins, wrong weight, wrong alloy, weak strike, to be traced back to its source. For collectors and historians, mint marks have accumulated a different significance. They are the geographic signatures of a coin's origin, tiny indicators of where in an economy the coin entered circulation, what trade routes it might have traveled, what hands it might have passed through on its way to the place where it was eventually found or preserved. Coins survive in conditions that destroy almost everything else made of organic material. The same density that makes a coin feel heavy in the hand makes it resistant to the processes that dissolve wood, fabric, leather, and paper across centuries of burial. A coin dropped in a field or lost in a shipwreck can lie in the ground or on the ocean floor for 1,000 years and emerge with its design still legible, its metal still sound, its weight still measurable. This durability has made coins one of the primary physical records through which historians piece together the economic and political history of ancient and medieval societies. A calendar of reigns, a record of which faces were considered worth commemorating, a trace of the metal supplies available in a given era, a map of trade routes drawn in the distribution of coins far from their place of origin. The study of ancient coins is called numismatics, and it is a field that sits at the intersection of history, metallurgy, art history, and archaeology. A numismatist examining a Roman denarius from a particular decade can draw from it information about the silver content the mint was using that year, the artistic conventions of the portrait workshop employed, the particular titles the emperor had claimed at that point in his reign, and sometimes even the specific mint workshop that produced it. The coin carries all of this silently, without needing to be read. It is the evidence itself, not a report of evidence. Running a fingertip across the surface of a 2,000-year-old coin is as close as it is possible to come to a direct physical connection with the economy of the ancient world, the actual object, not a description of it. The weight of a coin denomination, the specific quantity of metal that each piece was required by law to contain, was not chosen arbitrarily. In systems where the coin's value was understood to derive from the metal it contained, the weight was the value, and deviations from the standard weight were deviations from the promise the coin carried. The standards were set by governments and mints, expressed in precise terms that tied the denomination to a specified weight of metal of a specified fineness. A troy ounce of silver was worth a certain amount. A coin containing a certain fraction of a troy ounce of silver was therefore worth a calculable fraction of that amount. The logic was simple enough that any trader with access to a good scale and a knowledge of the current standards could in principle verify what a coin was worth by weighing it. This is why scales appear so frequently in scenes of ancient and medieval commerce, not as a symbol of justice, but as a practical commercial instrument for a world in which the coinage could not always be taken at face value. The physical space of a working mint, even a large and well-organized one, was not a quiet or especially comfortable environment. Furnaces for annealing and melting ran hot throughout the working day. The presses, whether driven by hand cranks, by horse-powered capstans, or by later steam engines, produced a sustained rhythmic noise. Metal blanks in various stages of preparation moved through the space in baskets and trays. The smell of hot metal and flux and the dust of the engraving workshops mixed with the smell of coal or wood from the furnaces. People working within that space for a full day were working in noise and heat and with materials that demanded close attention. The coins that came out were small, clean, and precisely made, the product of a process that was none of those things. The transition from screw press to steam-powered press happened gradually through the late 18th and early 19th centuries, as the Industrial Revolution made steam engines available as a general-purpose power source for manufacturing. Matthew Boulton, the Birmingham manufacturer and partner of James Watt, introduced steam-powered coining presses at his Soho Mint in Birmingham in the 1780s, and his mint subsequently produced large contracts of copper coinage for Britain and a number of other countries. The steam press offered greater speed, greater consistency of force, and the ability to process coin blanks at volumes that screw presses driven by human labor could not match. The coins produced by Boulton's facility were noted at the time for their quality, their evenness of design, their regular edges, their consistent weight, and the technology he demonstrated influenced mint operations across Europe and the Americas. Philadelphia's mint adopted steam power in the 1830s, and the change accelerated its production capacity considerably. The branch mints established in 1838 were equipped with the newer technology from the beginning. As the 19th century advanced, the scale of coin production in the United States grew dramatically alongside the economy it was meant to serve. The gold rushes of the 1840s and 1850s brought enormous quantities of new metal into the monetary system, and the mints were required to process it into coin at rates that would have been inconceivable to the craftsmen who worked the screw presses in the original Philadelphia facility. The machinery scaled, the workforce scaled, the administrative structure scaled. The fundamental operation, heated blank, 2 dies, controlled force remained. The coins accumulating in a wooden tray beside a Philadelphia mint press in the 1790s, or a Dahlonega mint press in the 1840s, or a L'Entresant facility press in the present day, share something that is not quite reducible to their metal content, or their design, or the machinery that produced them. They share a specific kind of social fact, the fact of being objects whose value is agreed upon and guaranteed by a recognized authority in a form that can be physically held and physically transferred. This quality made the coin the foundational technology of commercial civilization for more than 2,000 years, persistent through empires and republics and revolutions and the entire transformation of the world's economic arrangements. The technology by which a coin was made changed continuously across those 2,000 years, becoming more precise and more consistent and more mechanized with each major development. The social technology the coin represented, the portable, authenticated, durable carrier of agreed value, did not need to change because it already worked. In the Royal Mint's facility in Lantressant today, the automated presses run in a large, well-lit production hall that looks almost nothing like the dim workshop near the Roman Forum, where a moneyer lifted a warm silver denarius from a wooden board 2,000 years ago. The blanks that feed into the Lantressant presses have been prepared to tolerances the ancient moneyers would have found unimaginably precise. The force applied by each press is controlled by systems that measure and adjust in fractions of a second. The coins that emerge pass under optical inspection systems that check dimensions and surface quality and design depth at speeds no human eye could match. They fall into counting trays and are automatically tallied and sorted and packaged for distribution. The volume and the speed and the precision of the operation are entirely new, the product of 2 centuries of continuous mechanical innovation applied to a single set of practical requirements. And yet, when a finished coin tumbles into a counting tray in that lit room in Wales, it lands with the same small specific weight that the Roman denarius landed with in the workshop near the Forum, the weight of a precisely measured quantity of metal pressed into a standardized authenticated shape, ready to move from hand to hand across an economy, carrying the promise of value fixed by authority and accepted by use. The thread that connects those 2 moments across more than 2,000 years of changing empires and changing machinery and changing ideas about what money is, runs unbroken through the simple physical fact of the struck coin, a piece of metal that has been made deliberately and with care to be worth exactly what it says it is worth. The Lantressant presses continue their work through the long working day, coin after coin, the counting trays filling and emptying in the regular rhythm of a production line that is also, if you hold it in a wide enough frame, a continuation of something that began with heated metal and a hammer blow in a workshop lit by oil lamps and the glow of a small furnace, somewhere in the ancient world, on a day whose date no record preserved. A single dollar bill rests on an ordinary wooden table in the kind of room that exists in every city and every season. The overhead light is on. The bill lies flat, face up, slightly creased along one diagonal where someone folded it once and then smoothed it back out. Under that light, the texture of it is visible even from a small distance, a faint roughness across the surface, a weave of cotton and linen that gives it a feel unlike any other paper, more like cloth, slightly resistant between the fingers, holding its shape in a way that plain paper does not. Pick it up and turn it, and the ink catches slightly differently at different angles. The engraved numerals in the corners are not flat. They sit above the surface of the paper in a way that the fingertip can trace, tiny raised ridges left by a printing process called intaglio, in which ink is pressed into paper from an incised plate under enormous pressure so that the design stands up from the surface like a very low relief. Run a thumbnail across the number and it catches. The green of it is not quite the color of anything else, slightly cooler, slightly darker than the word green alone suggests, a tone arrived at through a specific ink formula that has remained in use for more than a century because it photographs poorly under the conditions that forgers work in. The bill weighs about 1 gram. Its material worth in terms of the cotton and linen fiber and the inks and the trace of metal thread woven into it amounts to a small fraction of a cent. What makes it worth $1 is not in the paper at all. What makes it worth $1 is an arrangement, not a contract signed by anyone who now holds one, not a promise made personally by anyone in particular, but a kind of collective agreement so widely maintained and so deeply habitual that most people who handle dollars every day have never once stopped to examine what the agreement actually consists of. The word fiat comes from Latin. It means by decree, by the statement that something is so. A fiat currency holds value because a government has declared it legal tender, and because the population that uses it has accepted that declaration through a combination of legal obligation and long practice. This is worth sitting with for a moment. The physical object is almost worthless. The institutional object is worth exactly what the shared confidence of hundreds of millions of people and a set of carefully maintained government arrangements say that it is worth. Those arrangements, the central bank, the legal framework, the credibility of the issuing authority, are the vault the money lives in. The paper is just the door handle. There is nothing fragile about this, as it turns out. The fiat dollar has been in operation since the early 1970s, when the last formal link between American currency and physical gold was severed, and in the decades since then, the dollar has remained the world's dominant reserve currency, held in central bank vaults on every continent, used in the pricing of oil and commodities from ports and exchanges around the world. The arrangement has proven extraordinarily durable. What makes it durable is not the paper, it is the depth of the habit, the breadth of the trust, and the scale of the economy that the trust is anchored in. A dollar bill lying on a table is in this sense a social fact. It exists the way that a handshake sealing an agreement exists, as the outward sign of something that lives entirely in the shared understanding of the people involved. The difference is that the dollar's handshake involves every government, bank, merchant, and pocket in a very large part of the world, and has been maintained in an unbroken chain of transactions stretching back for generations. The bill is still lying there on the table. The light is on. Nothing about it has changed. Not every place on earth made the same arrangements that produced that bill, or made them in the same sequence, or found them equally accessible. In the early years of the 21st century, large portions of the world's population remained outside the formal banking system entirely, not because they lacked money or even the desire to save or transfer it, but because the physical infrastructure of banking had never reached where they lived. No branch, no identification documents that met institutional requirements, no affordable way to move money across the distances that separated families and communities, and the places where work was available from the places where the money needed to arrive. In 2007, a telecommunications company in Kenya called Safaricom launched a service called M-Pesa, the name drawing from the Swahili word for money, pesa, built not on branches or counters or vaults, but on the mobile phone that a very large proportion of Kenyans already owned or had access to. The service was simple in its design. A user could deposit cash with a local agent, store that balance on their phone, and send any portion of it to another phone user anywhere in the country, who could then withdraw it as cash from another agent near them. No bank account required, no minimum balance, no physical distance that a text message could not cover. Within a few years, the number of users had grown to tens of millions. The value of transactions passing through the system each year reached a proportion of Kenya's total economic output that had no precedent for a private payment service in any developing economy. Families in Nairobi could send money to relatives in remote rural areas in seconds, Workers in cities could maintain households hundreds of kilometers away without the cost and uncertainty of transporting cash by hand. Small business owners who had never had access to credit could build transaction histories on the platform that eventually allowed them to borrow against their payment records. A woman standing at a vegetable stall in a small Kenyan market town might tap 4 or 5 digits into a basic mobile phone, confirm a recipient's number, enter an amount, and send money to a sister in a village 3 hours away by road. The transaction complete in the time it takes to set the phone back down on the wooden counter beside the tomatoes. The money arrives before the conversation about it ends. This is not a trivial change. For millions of people, it was the first time that transferring value across a meaningful distance did not require a physical journey, a trusted courier, or the risk of carrying cash through uncertain territory. The success of M-Pesa was studied carefully by governments, development economists, and technology companies in every part of the world. What it demonstrated was a principle that now seems almost obvious in hindsight, but was not obvious at the time, that the infrastructure required to participate in a financial system did not have to be made of bricks and vaults and printed forms. It could be made of signal. Signal is very good at traveling. It crosses mountains and time zones and the edges of formal economies. It reaches places where roads are seasonal and banks are rumors. What M-Pesa showed, in quiet practical terms, was that the social arrangement at the heart of money, the agreement to transfer value between people who trust a shared system, could be maintained on hardware that fit in a coat pocket, running over networks that already existed for other purposes. The mobile phone resting on that market stall counter in Kenya carries inside it the same essential logic as the clay tablet pressed in a Mesopotamian warehouse, the paper certificate carried in a merchant's coat across a mountain pass, the receipt written by a goldsmith beside a candle in a medieval vault. The form changes. The arrangement persists. Halfway around the world from that market stall, in the autumn of 2008, a document was circulating on a small technical mailing list used by people interested in cryptography, the mathematics of encoding and protecting information. The document was a white paper, 9 pages long, written under the name Satoshi Nakamoto, and it described a system for electronic cash that would operate without any central authority at all. No government, no bank, no institution whose credibility backed the value of the currency. Instead, the system would rely on a distributed network of computers that collectively maintained a shared record of every transaction, verifiable by anyone, controlled by no one. The paper was careful and precise. The system it described was elegant in a technical sense, solving a problem that had resisted previous attempts at digital currency, namely how to prevent the same unit of value from being spent twice without requiring a trusted authority to verify each transaction. The solution was a structure called a blockchain, a continuously growing sequence of transaction records, each one incorporating a compressed fingerprint of the one before it, so that altering any past record would require redoing the computational work of every record that had followed it, an effort that would outpace any single actor for as long as the network remained sufficiently large and distributed. In January 2009, the first block of the Bitcoin blockchain was created. Embedded in the data of that first block was a short text string taken from a newspaper headline of the same day, a reference to bank bailouts, to the financial rescue packages that governments around the world were assembling in the wake of the economic crisis that had begun the previous year. The message was placed there by Nakamoto, whose identity has never been confirmed. It read like a timestamp. It also read like a comment on the institutions whose absence was the premise of the new system being built. The identity of Satoshi Nakamoto remains genuinely unknown. Candidates have been proposed over the years, individuals with the right combination of technical skill, the right writing patterns, the right apparent knowledge of certain domains, and none of them have been confirmed. What is documented is that the account associated with Nakamoto's early mining activity holds approximately 1 million Bitcoin, and that wallet has never been touched. The coins have sat there since the network's earliest days, unspent, neither moved nor sold, a quantity of value that has fluctuated enormously in monetary terms, but has remained in exactly the position it was placed in, like a sealed envelope in a locked drawer. A screen displaying the Genesis block's embedded text looks like almost nothing at all. A few lines of plain characters on a pale background, the kind of thing that passes for nothing until someone explains what it represents. The first record in a system designed to have no first authority. The starting point of a ledger that was intended never to close. Bitcoin is not the only form that the question of digital money has taken. Governments watching the growth of cryptocurrency networks and private digital payment systems through the early decades of the 21st century began to develop their own answers, not decentralized, not operating outside institutions, but digital in form, issued and controlled directly by central banks in the way that physical currency has always been, without the intermediary layers of commercial banks and payment processors. China moved further and faster in this direction than any other major economy. The People's Bank of China began serious development work on a central bank digital currency, officially called the ECNY, in the years following Bitcoin's emergence, and by 2020 had begun distributing it through pilot programs in dozens of cities across the country. The digital yuan was not a cryptocurrency in the decentralized sense. It was in structure closer to a digital version of a physical banknote issued by the state, held in digital wallets, and spendable anywhere the infrastructure to accept it had been put in place. Residents of pilot cities received ECNY through lotteries that distributed small amounts to millions of citizens who could spend them at participating retailers, pay for public transit fares, and in some cases receive portions of their salaries in the new form. A municipal worker waiting at a bus stop might unlock a phone and see a balance update, a salary disbursement recorded not as a bank transfer arriving through a commercial institution, but as a direct addition to a digital wallet maintained by the central bank itself. The transaction recorded in real time on a central bank ledger, the intermediary removed. The ECNY carries with it a set of characteristics that distinguish it from either physical cash or the existing digital payments that move through commercial bank accounts. It can be programmed, set to expire, or restricted to certain categories of spending, or tagged for specific purposes in ways that physical cash and conventional bank transfers cannot. The government retains the ability to see, at the level of individual transactions, where money moves and what it is spent on, in ways that the anonymity of physical cash has never permitted. None of these characteristics are hidden. They are documented aspects of the system's design. What the digital yuan represents in its clearest form is an extension of the state's monetary authority into a domain that cryptocurrency had opened up, and a demonstration that the technology underlying decentralized currencies could serve centralized purposes equally well. Money, it turns out, is very good at taking whatever form the institutions around it require. The clay token in Mesopotamia served the temple's accounting needs. The folded paper certificate served the merchant's need to avoid carrying heavy coin across mountain passes. The goldsmith's receipt served the property holder's need to leave gold in a safe place and conduct business with something lighter. The digital yuan serves a state's interest in maintaining the advantages of programmable, traceable digital money, while retaining the authority that has always sat at the center of currency issuance. Each form is a solution to the specific problem its moment presented. The question of what form money takes is, in this sense, always also a question about what kind of arrangement the society around it is trying to maintain. The arrangement changes, the money changes with it. At the far end of the spectrum of cashless transition, far from the pilot cities of China and the mobile networks of East Africa, is Sweden. Sweden, in the early decades of the 21st century, became the most documented example of a high-income economy moving away from physical cash at pace, not because the government mandated the transition, but because the population found alternatives sufficiently convenient that cash began to feel, to many people, like an inconvenience rather than a necessity. The numbers are precise and somewhat arresting. Around the year 2010, roughly 4 in 10 Swedes reported that the most recent purchase they had made had been paid for with cash. By 2020, that number had fallen to fewer than 1 in 10. Within a single decade, cash had gone from a plurality choice to a marginal one, displaced largely by card payments and by a mobile payment application called Swish, launched in 2012 through a collaboration between Sweden's largest banks, which allowed instant person-to-person transfers tied to a phone number. The Swish application spread quickly through exactly the kinds of transactions that had previously relied on small denomination cash, splitting a restaurant bill, paying a neighbor for a shared grocery run, handing a teenager money for a school trip without handling paper at all. A customer in a quiet Swedish cafe on a winter morning might tap a phone against a small white card reader the size of a matchbox, hear a soft tone, and have the coffee paid for before the cup stops steaming, without either person in the transaction having touched a physical note or coin. The cafe might not have a till with a cash drawer at all. Some Swedish churches began accepting donations by card. Market vendors brought portable readers to outdoor stalls. This is a change that happened mostly below the level of formal policy, carried forward by individual preference and the gradual withdrawal of the friction that cash once created. Younger Swedes, in particular, moved away from cash so completely and so early that for many of them physical currency became associated primarily with older family members, with tourists, and with a certain residual awareness that something called cash had once been the main way that small transactions were settled. The transition has not been entirely frictionless. Older residents, people in rural areas, and individuals who for any of a number of practical reasons lacked the documentation, the smartphone, or the banking relationship required to use digital payments, found themselves increasingly unable to conduct ordinary transactions with the physical currency they had always relied upon. Banks reduced their cash handling, ATM networks thinned. The infrastructure of cash, the supply chain that produces it, counts it, transports it, accepts it, contracted as demand for it fell, and the contraction itself further reduced the convenience of cash, creating a feedback loop that accelerated the transition. The Swedish government, watching this, began studying the question of how to protect citizens' right to access and use physical cash, even as the market moved decisively away from it. The question was framed not as a debate about whether the cashless transition was desirable, that transition was largely accomplished, but as a matter of ensuring that a functioning cash infrastructure remained available for those who needed it, and that the right to pay in physical currency retained legal meaning, even in an economy where the practical exercise of that right was becoming increasingly unusual. What Sweden's experience makes visible is something that lies just beneath the surface of money in every form it has ever taken, the tension between the convenience of an arrangement and its universality. Every advance in the convenience of money, from the paper certificate that replaced a chest of coins, to the banknote that replaced the goldsmith's receipt, to the phone tap that replaces the banknote, leaves behind it some population for whom the new convenience is not accessible, or not trusted, or not appropriate, and for whom the system has to be deliberately maintained in parallel. The clay jar sealed in a Mesopotamian warehouse, the cowrie shell carried from an island market, the round bronze coin strung on a cord, the stamped disc of electrum pressed flat on a merchant's counter. Each of these was once the new form, arrived at because it was more convenient than what it replaced, and each of them eventually became the old form, retained for some purposes and by some people, while the next arrangement spread outward from wherever it had begun. Money does not have a final form. It has a direction, always toward whatever allows the social arrangement of exchange to function with less friction, less risk, and greater reach. The form is a vehicle, the arrangement is the thing. On a still morning in Stockholm, very early, before the city's working day has begun, the Swiss servers are processing transactions. Not the major ones, those will come later when businesses open and offices fill. These early morning transactions are the small ones, a payment sent the night before arriving at its destination, a subscription renewing on its scheduled cycle, a transfer between two people who live in different parts of the country, settling something arranged by message the evening prior. The activity is low but continuous. The network does not sleep, even when the people who created it are sleeping. The servers sit in a lit room somewhere, a data center, climate controlled, its equipment racked in rows, indicator lights blinking in the pale blue of standby systems. Outside, the Swedish winter is doing what it does at that hour, cold air lying flat across the city, the sky beginning its long, slow movement from deep dark toward the gray that precedes the sun, street lights on because the light will not come for some time yet. The streets are very quiet. The buildings are dark in their upper stories. The trams have not yet resumed. And still the transactions move, a value transferred from one account to another in a fraction of a second, a balance updated, a record written to a ledger that neither party to the transaction will ever inspect. The math resolves, the numbers match, the arrangement holds. There is something in this that echoes very far back. A record keeper in a dim room somewhere, pressing a tool into a soft surface to note a quantity transferred, the numbers resolving, the balance holding, the arrangement maintained across another night. The tools are unimaginably different. The task is the same one. Money, across all the forms it has taken, has been the record of an agreement between people who are not in the same place at the same time, maintained by whatever systems their moment had available to maintain it. The tablet, the shell, the coin, the certificate, the printed note, the phone, the server, each one a different answer to the same enduring question. How do we keep track of what we owe each other, and how do we make that record move? The servers continue, the transactions continue. Outside the data center, across the country, people are asleep in warm rooms, their phones on nightstands or beside beds, the balances in their accounts static for a few more hours, the network patient and steady around them. A dollar bill still rests on a table somewhere. A coin minted in a facility in Wales carries an image pressed into its surface by a machine, running a continuous automated cycle, each coin identical to the one before it and the one after. A woman in Kenya will reach for her phone in a few hours when the market opens and the transactions of an ordinary day begin. A central bank digital wallet in a Chinese city holds a balance that will be spent on transit and food and small ordinary purchases before the week is out, each transaction written to a ledger the size of the country's ambition, and in a wallet address on a distributed global network. Approximately 1 million bitcoins sit exactly where they were placed more than 15 years ago by someone whose name has never been confirmed, in a sealed corner of a system designed to need no authority to run and no permission to use, the balance visible to anyone who looks and spendable by no one who doesn't hold the key. The question of what money is has no answer that stays still.